This is your video for section 6.2. In this section we're going to start talking about how to solve trig equations. These are going to be fairly simple equations in this section. In section 6.3 we'll look at some more complicated types of equations. So first we've got some tips for solving these. The first one is to look at your equation and determine whether it's a linear equation or a quadratic equation. And there are some other possibilities too besides just these two, but if it's one of these two you can determine that. And that helps you decide where to go from there as far as solving the equation. So a couple of examples of these. If we're looking at a linear equation, this would be something like this. So there's only one trig function involved and we don't have any exponents in there. That makes it linear. A quadratic form equation could be something like this. It's just where you have a trig function that's squared or to even a higher power than that. So here are some different hints for solving trig equations, and this all depends on what you have in the equation. So if there's only one trig function that's there, then what we want to do is solve the equation for that function first before we go on to the next step. So if we go back to this equation that we had up here, this one would qualify for this. There's only one trig function in here, and that's tangent of x. So we would want to start by solving for the tangent of x. In other words, getting it by itself on one side. To do that, we would just add 5 to both sides. So we would have 3 times the tangent of x equals 14. And then we would divide both sides by 3. So we would end up with tangent of x equals 14 over 3. So that would be the first step in solving this equation. Then the next hint is that if you have an equation with more than one trig function, or if you have an equation that's quadratic in form, then what you want to do is rearrange the equation so that one side is equal to 0. Then what you're going to do is try to factor the other side and set each factor equal to 0. So just like what we did in algebra when we had a quadratic equation that we could factor, and then we set each factor equal to 0. So here's an example of that. This one would be quadratic in form because it has a cosine squared. So we would want to get everything on one side so that we have a 0 on the other side. To do that, we could just subtract cosine of x from each side. Then we'd want to factor this. Both of these terms have a cosine of x, so we could factor that out. What we would have left would be 2 cosine of x minus 1. So now we have our two factors. This is one factor, this is the other factor. To go on from here, we would set each factor equal to 0 and then solve for cosine of x. Here's another example that has two different trig functions in it. This equation has both sine and cosine, so we want to do the same thing. We want to try and get everything on the same side. We could do that here by subtracting sine of x from both sides. That way we have a 0 on this side, and then on this side we have a sine of x in each term, so we could factor that out. That gives us sine of x times cosine of x minus 1. And then we would take each factor and set it equal to 0. So in this one we would have sine of x is equal to 0. We could go on and solve from there. This one we would have cosine of x minus 1 equals 0. We would want to solve this for cosine of x. And then we would go from there with each one of those two. The next tip is that if the equation is quadratic in form but you can't factor it, then you're stuck with using the quadratic formula. So here's an example of something like this. This one, we know it's quadratic in form because it's got the sine squared. So to tell whether we can factor this, let's kind of rewrite this with an x in place of the sine of theta. That's just going to make it easier to look at. So instead of sine squared theta, we've got x squared, and here instead of sine of theta, we've got x. So this one, if we try to factor it, it's not going to factor. So then we'd be trying to use the quadratic formula. We can leave it like this for now and just use the x here. So for the quadratic formula, our a would be 2, our b would be -1, and our c would be -2. Then we could go ahead and simplify this, but keep in mind that the x in the first place was actually sine of theta. So what we're going to end up with here is 2 values for the sine of theta. Under the radical, that simplifies to a 17. So we would have something like this. So we've got it solved for sine of theta, and then we would have to go on from there and solve it for theta. Now the last one of these tips is to try using identities to change the form of the equation. If you can't see anything else to do, then you might be able to use an identity. If you have something like a sine squared plus a cosine squared that are both on the same side of the equation, you can take those two and replace them with a 1, something like that. You can also try squaring each side of the equation first. If you do that, you'll have to check your final answers because you can end up with extraneous solutions when you use that method. So an example of this would be if we had something like this equation. But this one, if we look through our other tips, this has 2 different trig functions in it, but if we try to subtract 1 from each side, then we're not going to be able to factor that anyway. So the next thing that we could try would be squaring each side. Remember, if you're squaring a binomial, you really have to write it out twice and FOIL it. So what we would end up with, if we did that and combined our like terms, would be cosine squared x plus 2 cosine x sine x plus sine squared x. And here we can use an identity to simplify this. We've got cosine squared x and a plus sine squared x. Those two together are just going to equal 1. That's our Pythagorean identity. So that would give us 1 plus 2 cosine x sine x equals 1. Now we still have a trig equation with 2 different trig functions, so we want to try and get a 0 on one side. That'll happen if we just subtract the 1 from both sides. We'll end up with 2 cosine x sine x equals 0. Then we can go from there, and we've got basically 2 factors here. We've got the cosine x and the sine x. We would set each one equal to 0 and solve it from there. Now in all those tips, we got to the point where we had a trig function that was equal to a number. At that point, then we're going to use an inverse trig function to actually solve the equation and find the angle. The first equation we talked about, we ended up with tangent of x equals 14 over 3. Let's say that we wanted the solution for this in the interval from 0 to 2 pi. This is something you have to look at because this is going to tell you whether your solution should be in radians or degrees. This would mean that our solution is supposed to be in radians since it used 2 pi. What we want to do here is use the inverse tangent. So the inverse tangent of 14 over 3 would equal x. This one we could put in our calculator and get an approximation for it. The other thing that's going to happen here is that most of the time with these, we're going to end up with 2 solutions if we're looking for solutions between 0 and 2 pi or between 0 and 360 degrees. This one, because we had a positive number here, this is going to give us a first quadrant solution. If we use our calculator, then we're also going to have to figure out if there's another solution between 0 and 2 pi. For this one, because it's tangent, tangent is also positive in the third quadrant. Which means we're going to have another solution. We can use our first quadrant solution as our reference angle and then figure out the third quadrant solution from there. But that's something to always be aware of, that for the most part, you're looking for 2 solutions in between this interval. If you're using your inverse trig functions, that's going to give you one of the solutions. you're most of the time going to be looking for two solutions.